Okay, this podcast is for CNT140. We are going to be looking at Chapter 11 of fiber optics. Now, we have a number of different goals in here of reviewing some fiber basics and connectors and construction, those kinds of things, installation, safety. But we also are going to hit we're going to hit a couple new things here. I'm going to do a couple demos on fiber transmission, and then we're also going to do just a couple review of some things we talked about in an earlier chapter. So here's what I'd like to do to tackle this one. The first check, I want to go over some history. This is going to give us a chance to talk about some principles of light and how light is transmitted. Then we'll talk about how fiber optics made, because that always comes up of, well, how does this get made? And this will give us a chance to talk about sizes and multi-mode, single mode, all that jazz. Third, we'll talk about some of the technical details, including connectors and connector types. And then fourth, we'll talk about some of the limitations of fiber, because we have to address that. Alright, so the first part here, let's talk a little bit of history about fiber optics. I'm not hung up on you remembering this, but this will give us a chance to talk about some principles of fiber and how light is transmitted. That's one of the reasons we're doing this. If we look about almost 2,000 years ago, we had some early philosophers, mathematicians, astronomers, those sorts of things that were writing about the properties of light, including some basics of reflection, refraction, that sort of thing. So this is something that's been, the idea of moving light and doing stuff with light, this idea has been around for almost 2,000 years. So the principles of fiber optics is nothing new, but it's basically back in the beginning of working with light. What can we do with it? Around 1,000 years ago, we have a mathematician, physicist, looking at how can I take lenses, mirrors, and bend light, focus light, doing that sort of thing, and is actually credited with the beginning of Snell's law, which we'll get to in a minute. We have around 500 years ago, Kepler, I should say a lot of you probably recognize Kepler from planetary motion and our elliptical orbits of planets and those sorts of things, was also exploring light and traveling light and how light travels in straight lines, casts shadows, it bends when it moves from one substance to another. So these are some of the initial principles on how light is transmitted. So what I'm going to do here, let me quick highlight the next couple of videos you're going to see. I have a demo video that's going to be next in line here that's going to show you this idea, light traveling in a straight line, and then also how light bends as it moves from one substance to another. Now this is really important because as I'm talking fiber optic, if you remember back when we talked in CNT140 about fiber construction in Chapter 5 in this class on fiber optic construction, we talked about the core and cladding of the fiber. The core is one substance, the cladding is a different substance. Well, they're both glass, but they have different indices of refraction. So as light is going to leave the core and hit the cladding, it's going to bend. This is important. So I'm going to show you with a tank of water, light moving through a tank of water and the light bending. I will show you that. That'll be the next piece of the next demo. And then as we move again, we're talking 400 to 500 years now, we have Snell's law basically defined for us, the idea of the law of refraction. And I'm going to show you in the next video another demo of light moving through a bar of acrylic as well as a curved bar of acrylic to show you that light can bend around the corner if we give it a path. So I'm going to pause here. The next video in line is going to show these demos to you, and then we'll continue on with some of our history of fiber.